not only create the graph, but know what the important characteristics are. All right. For certain things like polynomial functions, it's pretty easy because it's just a matter of finding x and y intercepts, things like that. But when it comes to periodic functions, we need to know what those the important characteristics, such as extreme values, x and y intercepts, of course, but also if it's a periodic function, that means that it repeats itself periodically. So we'd want to know in what way it repeats itself. In order to do that, we need to know these important features, amplitude, period, and so on. All right. So to pull that information out from an equation is very straightforward as long as you know the general form. General form is y equals a times the sine of bx plus c plus d. All right. Also works for cosine. I mean, it also works for cosecant, cotangent, and all that good stuff, just in a slightly different way. All right. We're only going to focus on sine and cosine because hopefully over the last couple of years, one thing that you pulled away from your studies involving trigonometry is if you know a whole heck of a lot about sine and cosine, you can kind of figure everything else out. All right. Because if it's a question involving tangent, you're like, oh, I don't know anything about tangent except tangent is sine divided by cosine. So let me first make that move, and then I'll just use my knowledge of sines and cosines. All right, and everything kind of works itself out. All right, the amplitude is the a value, but specifically the absolute value of that a value. All right, the period. Now, I will preface what I'm about to say by saying that there are other variations of the standard, it's called standard form for a trig function. This is the general form. So there are other ways to model trig functions aside from what I'm writing here, but this is the most user-friendly way. All right, the period formula, 2 pi divided by b. Phase shift, negative c divided by b. And the vertical translation as in how far you shifted either up or down, is just the d value. All right. The phase shift is how far you would shift the graph left or right. All right. So looking at our equation here, we can pull out the a, b, c, and d values. The a value is 3. The absolute value of a positive number is just that positive number, so just 3. The period is going to be determined by first finding the b value. The b value is the coefficient of x, which is 2. So 2 pi divided by 2 is going to be pi. All right, so that means that it's going to take pi units to complete one full cycle of a sine wave. If you remember the general structure of a sine wave, you would know that you're going to complete that full cycle between 0 and pi. All right. The phase shift is determined by first finding the b value, then the c value. The c value in this case is a negative pi. Negative pi over 2 is going to be pi over 2. All right, so that's telling us that we're shifting our sine wave pi over 2 units to the right. All right. Now, very important, the term cosine, you probably know this, stands for complement of sine. Complement is a 90-degree shift. All right, so if you have a 0-degree angle, then its complement would be 90 degrees. Right? It's just a shifting over of 90 degrees. Right? So if you shift if you shift a sine wave 90 degrees or pi over 2, you get the cosine graph. All right? The d value is your vertical translation, which in this case is just a positive 2. Now, after that, if you want to graph it by hand using this information, by all means go for it. I'm never going to require you to do that. All right? Those days are over. All right, now that you've identified the important features, pop it into Desmos or the TI calculator and go from there. The good thing about Desmos is, and really to some extent the TI, you type it in just as you see it and you'll get the answer. All right, so y equals, in this case, 3 sine. So 3 go to functions, or just type in, if you're using the keyboard, type in the word sine. It'll start off in italics. Once it recognizes that as an appropriate function for Desmos, it'll change it to ordinary font and you'll know that it's locked in. All right, but I'm going to tap on trig, sine, in this case 2x minus pi, close it up, add 2. All right, another thing I'm never going to ask you to do in this class is make a graph by hand. So what I would do if I were in your position is I would just create a share link for this and submit it, assuming it was a question on a test that said create a graph. It'll never be a question on a test saying create a graph, but if you have a question that requires you to create a graph in order to solve it, so like it doesn't explicitly say create a graph, but you want to solve the equation by creating a graph, then you'd submit your Desmos link. You wouldn't actually just draw it out. All right. So the only thing is you just want to get the scale to be roughly equivalent. So there's a couple of ways to do that. One would be to actually plot the pi on the actual x-axis. So the way I would do that is plotting, oops, I was right where I needed to be, pi comma 0 to give it a sense of scale. Just so you meet the requirements of the assignment, it said to do it between negative 2 pi and 2 pi. So if you want to truncate a graph, you don't want the whole thing, you just want part of it, tap at the end of it, open a squiggly set of brackets. So in the ABC, you'll see the squiggly open. Open that squiggly bad boy and type in the domain in inequality notation. So in this case, negative 2 pi less than or equal to x less than or equal to 2 pi. And then hit enter or tap out of it and you're good. You have your truncated graph in the appropriate domain. Submit it. I'm just going to do a screenshot and pop it in. But there's no point in this class where I'm going to ask you to physically draw a graph. You might choose to do it, because I mean, I got to imagine there's somebody in this room right now who's like, I'd prefer to draw it than do what you just did, So, and I understand that. That's perfectly fine. But I want to make sure everybody has the option to create stuff on Desmos if they want to. All right, it's gonna look like garbage, but I'm just gonna pop it right there. Now, the second part, which I think is probably the most important part, write an equivalent equation using a cosine function. All right, so this is where things get interesting. So I got to make another equation that's going to map out this exact same curve, but using a cosine function. So using Desmos, instead of going nuts with things like phase shifting and all that good stuff, the first thing I'm going to try to do is put an equation in general form for cosine into Desmos. So what I mean by that is type in y equals a cosine bx plus c close it up plus d. All right, you'll see it prompts you to add sliders, A, B, C, and D. So select all. It'll create a cosine wave, which I guess could also be interpreted as a sine wave, that will be dependent on the values of the sliders. In this case, one for all of them, A, B, C, and D, because that's what the default setting is. Now, I want my amplitude to be the same amplitude as the original graph. So I'm going to slide that slider over to 3. With the touchscreen, sometimes it sticks. If it does, just type it in. All right. My vertical translation should also be the same. You can see here, I'll just I'll toggle it off and on. You see it's too low. All right. I want it to go up, so I'm going to move my D value up to 2. All right. The amplitude and the vertical translation should be exactly the same, regardless if it's a sine or cosine in this situation, because the only difference between a sine and cosine is the horizontal movement, nothing involving the vertical movement. All right. So this graph, at least the one I'm using to map out the one that they gave us, is too wide. thought I changed these settings. It's definitely too wide, so I want to squeeze it in. All right, so that's gonna impact my frequency value, the B value. But also, I'm gonna most likely have to shift it over some. All right, but in this case, we have a phase shift of pi over 2, which is the definition of the transformation from sine to cosine and vice versa. So in this case, we might get away with it. All right, so what I'm going to do is I'm going to kind of play as if I don't know what the answer is, and just kind of slide my slider around until I get something that matches up, or at least looks appropriate. All right. So size-wise, it looks like we're pretty much kind of in the neighborhood, but I'm looking at something that's definitely further to the left than I want it to be. I could get it to almost fit on that first loop to the right of the y-axis, but it misses everywhere else, so that's no good. All right, but it looks roughly parallel, like right here, when b is equal to 2. So that's good. And that also confirms that the frequency should be the same as the original problem. So now I just got to get the shift. All right, so I got to shift my purple graph so that it lands right on the blue one. All right, the C value is going to control that. So just get the movement over. Looks pretty good right there. 1.6, 1.7. That's a pretty decent fit, but it's not exactly gonna fit. So that if you're gonna solve for anything in this problem, it's probably gonna be the C value. But if you start thinking about factors of pi, you know, because most of the time it involves a pi. If you're thinking about factors of pi that are close to 1.6, you might land on pi over 2. So what I would do here is I would type in, oops, hit the wrong thing, type in pi over 2. 1.57-ish. All right, so I had to take a little bit of a guess, but it looks like it's a good fit. All right, so now I could turn this off and on, and you see that it's a perfect fit. All right, so now I have my A, B, C, and D values, and I'm looking at y equals 3 cosine, the B value is 2, x plus pi over 2 plus 2. And that's an equation that would map it out. I mean, there's actually other equations that you could use, but that's a good one. All right. So this is an important concept because when we start doing the project for the unit, part of it is going to involve you coming up with equations to map a particular graph. All right. And you're going to want to know how to do this kind of thing. So if you look at it and say, okay, well, what if I tried doing this with a parabola? You could actually try to fit a parabola to at least one part of this. You're just not going to get it to go through all of them, obviously, because a parabola is not a periodic function. All right? But if you have something that's periodic in nature, then you could use a trig function to map it out. All right? So that's where we're going to stop in terms of the direct instruction. You have more time to continue working in your packets, work together, talk it out, and go from there. Ask me questions, ask each other questions, of course. I'm thinking Wednesday.